Hello, guys. Welcome back to Math Zone African Motives, still on industrial electronics N4. In this platform, we shall be focusing on AC theory. Yeah, that's AC theory from July 2022 question paper. We have a question that we are given on question number 2. The first part, it was clear. Just you need to know, guys, your basic information, just basic information. Indicate whether the following statements are true or false by writing only true or false next to the question number 2.11 up to 2.14 in the answer book. Okay. 2.11, we're given an imaginary number is a number that when squared gives a negative result. Is that so? Okay. We know that an imaginary number, guys, that's a j, which is equivalent to square root of -1. That's a j is equivalent to square root of what? -1, or someone can use it as I, but we know that j is the best for engineering. So they are saying if you square it, is it going to give us a negative? Yes, guys, if you square this, j squared is equivalent to -1. Remember, from your laws of sets, okay? And from your complex numbers, that j squared is equal to -1. So truly, this is true because our answer is a negative. So this is actually true. Okay, 2.12, it is inconvenient to add or subtract phasors using a rectangular form. It is inconvenient. Is that so? No. There's nothing. This is false. Okay, so you actually need a rectangular. If you add the phasors, you actually need in rectangular form. But if you are multiplying, then you need in polar form. But rectangular form is best for adding, subtracting. Okay, 2.13. In an RLC parallel resonance, the impedance is equal to the resistance, whereas the inductive reactant is equal to the capacitive reactant. Okay, the impedance is equal to the resistance. Okay, that one is a no. It is equal when you are dealing with if you have got series resonance. Okay, for series resonance, that is where we have got that type of a consideration. But in this case, that's a no, because that one is called dynamic resistance, that you will be with dynamic impedance, that's the one that you're working with. So this one, it's a false. Okay, so that's a false here. 2.14, the quality factor, that is the Q factor, is the ratio of reactance to its equivalence, resistance. Okay, that's true. Remember, quality factor can be XC over resistance, or it can be XL over resistance. So that's reactance over resistance. That's true. All right, so this is actually true here. All right, so that was question 2.11 up to 2.14. We move on to the other part of the question, that's 2.2, where we are given a fig here. And from this diagram, we are given that, take note, guys, we are given, it shows the resistance of 40 ohms, inductance 0.19, the capacitance of 1. Take note, I want you to take note on the information here, you are given the capacitance of 110 microfarad. But on the diagram, you are given a capacitance of 130 microfarad, which is wrong. Okay, so here we are going to use 110 microfarad as given on the information. You use the information, but let's say you used the information on the diagram. They are going to mark that one because that is what you see on the diagram, but you are using 110. That is so read this information, guys. It's for you, this information, okay? Then it's connected across a 200 volt supply, which is the AC, and 60 hertz. Okay, so as you can see here, we've got 60 hertz and VT, which is 200. So which means we have got 200 volts here, which is our VRMS. Okay. Okay, so that's it. That's it. Okay, our diagram is fine. Let's check what we are given here. Question 2.21. Calculate the following using J notation. Okay, so we are given to use J notation because you can work this one using the simpler version. Then you can use the complex numbers, which is the J notation. Okay, 2.21, the current in each branch. So take note, you need the current in each branch. That is here, the current in the in the resistor, the current in the inductor, the current in the capacitor. All right, so that's it, guys. And this is pretty clear type of a person. Okay, this is pretty clear, guys. Okay, let me just write this aside. Okay, I'm just going to, just pardon me, guys. I'm just going to change this background a little bit. All right, so that's it. So what I'm going to do is to work out these separately, guys. You know, a resistor, if you are calculating the current in a resistor, so this is 2.21. So the current, let's start with the resistor, is the easiest one. The current in a resistor, we just know we need the supply voltage over the total resistance. But remember, this is J notation, okay? So the voltage that we have, that's 200 volts, the supply. So remember, guys, our supply voltage is 200 volts. And the angle here, because we are dealing with this, it's an angle of 0 degrees. That's the phasor angle, okay? It will be at 0 degrees. Okay, so the resistance, definitely it's at 0. There's nothing for the resistance, guys. Remember, the resistance, there's nothing. So the voltage is at 200 volts at angle of 0, phasor angle. The same with the resistance. The resistance was 40 ohms and the phasor is at 0. So if we divide 200 divided by 40, that's 5 angle of 0 like this. Okay, so that's the current which is going to flow. But we are given to use the J notation. Okay, so this is what you have on your calculator. Let me just share the screen so that you can see what to do on your calculator. You can leave it like that, but since it's J notation, you can also write it as a J. So this is polar form, the one that we have here. It's polar form. So you want to convert to rectangular form. So this is what you're going to do on your calculator. It's shift, you change to rectangular form. So it's shift, you go to minus there where there is written rec, there's a rec there. It's rectangular form. So it's a shift, you go to that minus, as you can see, it's now writing rectangular form. So it's 5. Then the angle here of 0 degrees, you write it like this. It's a shift, you want this comma on this part here. Is it going to give us what exactly we want? Because that one is actually something. So like this shift, you move on to this. So that's 0 like this. I don't know on this calculator. Yes. So on this calculator, it gives us the value of x and the value of y, to say x is 5 and y is 5. So here on your calculator, they actually mean that z, a polar in Cartesian, can be written as x plus jy like this. So that is the indication on the calculator. So this can be written as x. Our x, remember, we are given that x is 5. So this is 5 plus j is 0 like that. Okay, so you can write your current in this manner, or you can write it like this, of which this is the best way to write in polar form. Here I was just showing you guys how to convert these, how to change, but just leave it in polar form. It's fine like that. Okay, so that's it for the current in the on the resistor that we had. We move on to the other part. That's the inductor. So we've got an inductor there. So the current in the inductor is going to be given by this formula. The current in the inductor is going to be the supply voltage that we had over the impedance now, which is across the inductor, or you can write it as XL. Okay, you can write this as XL, or the impedance across the inductor, or XL. Okay, so remembering that XL, we have to calculate XL. This one you are given on your formula sheet, that XL is equivalent to 2 pi FL. All right, that's 2 pi times the frequency, of which we are given, guys, the frequency here on the diagram, that's 60 hertz. So you multiply to 60. All right, times the inductance, which is L. The inductance is 0.19. Okay, so that's 0.19. So that's it, 0.19. So on your calculator, please make sure that you use your calculator properly here. We are going to obtain something like 71.628 or 628 ohms. Okay, but remember that inductance, it leads. So which means it is supposed to be having in this format. Because remember, okay, let me write this way. We're supposed to have the resistance, okay? If it is the impedance, okay? We are supposed to have this as the resistance plus JXL, or actually this is like ZL. But we do not have this resistance. So in place of the resistance, you write it as 0. Okay, so which means therefore our XL can be written as 0 plus JXL, which is the one that we got here of 71,628, like that. Okay, of which we know that it's an inductor, guys, leads by 90 degrees. So it can be written in polar form as 71,628, and you indicate with an angle of 90 degrees. Okay, let's say you do not know, you've forgotten this part. You can use your calculator again to convert this to Cartesian, to polar form. From this rectangular form, this was rectangular form, you convert to polar form. So how do you convert to polar form? Just like what we did, but this time we want to convert to polar. So it's shift polar, which is shift polar. It's here on plus, there's pole, there is for polar form. So it's shift plus, as you can see, it's now polar form. So you write the number as it is, 71. You use this comma as it is, comma 628. Then for the 90 degrees, this one, sorry. I'm writing the other way. It was not, we are converting from rectangular. We want this here. We want this one 0 and this one. Okay, so this is 0. Then you separate this, shift, you go to this comma here, shift, comma like that, which is 71, comma 628, like that. Okay, so you close this. So it gives you in polar form. Remember, in polar form, your resultant in polar form is given as r theta, like that. So it gives you the value of r and the value of theta. That is the one that they are giving us here, which is our r is 71, comma, which is this one. Our theta is 90 degrees. As you can see, we are having it like that. Okay, so that's it. Our calculator can even assist us, guys, as we can see. All right, anyways, we now have XL. The issue is not on XL, but the issue is on calculating the current in the inductor. So therefore, the current in the inductor, V, is not going to change, is still the same. That V, which was 200, remember it was 200 angle of 0, divided by XL, which is 71,628, an angle of 90 degrees. So remember, this is polar form. In polar form, you divide the numbers together. So you divide 200 and 71,628. So if you divide these two numbers, you're going to obtain 2,792. Then for the angles, if you are dividing, you subtract these angles, okay? So for the angles, you subtract. So it's this angle minus this angle. 0 minus 90, that's minus 90, okay? So it's going to be minus 90 degrees. Okay, so this is the current that we have as the supply, all right? Sorry, as the current in the inductor, not the supply, but the current in the inductor, guys. Okay, so that's it. We move on. We are now on the capacitor. We have got the current in the capacitor now. So it's going to be supply over XC. So you have to calculate XC just like what we did on XL. So XC is given by the formula 1 over 2 pi FC. Okay, so we can substitute our values. So that's 1 over 2 pi. The frequency was 60, but take note on the capacitance, like I explained, I am going to use the one that they gave us on top here, not the one on the diagram, but this one, 110. So that one on the diagram, maybe it was just a mistake on redrawing when they were drawing the diagram. So we use the information, but in case like you use that one, it's still fine. So that was 110 microfarad. So micro means times 10 to the exponent of -6 from your N3, guys. I hope you know this from your N3. All right, so this is going to give us 24,114. So that's 24,114. This is a capacitor where we know that our actual answer is supposed to be R minus JXC. So that means in this case, therefore, our XC is going to be R, which is 0. We do not have the resistance, so that's 0 minus J. XC, the one that we got here of 24, so it was 24,114 ohms. Okay, so this is your XC. You convert this to polar form, or if you know that it's a capacitor, guys, which it lags by 90 degrees. So our XC is supposed to be 224. So supposed to be like this. It's supposed to be 24,114 angle of minus 90 degrees. Or if you do not know this, then let's get back to our calculator. Just like the previous part, we can convert to Cartesian form, which is the rectangular form. So to rectangular form, it's shift rec, which is shift minus, then you write your number 24, comma here, this is your comma, 114 like this. Then you separate with minus 90. So to separate, it's shift, you put this comma, that's negative 90 degrees. You close the bracket. Okay, so it is going to give you the value of X. That's a 0, the value. Okay, so it gives us the answer that we got there. Okay, still it's one and the same thing, but I did it the other way. Okay, anyways, it still gives us this answer. I hope you understand, guys. So I want you to get back to that one and see if you're going to get this XC. All right, so after finding XC, then we can find the current in the capacitor. That's V, which was the total voltage of 200. This one does not change for all of these. Why does it not change? It's a parallel combination, and we know that voltage is the same in a parallel combination. I hope someone is surprised. Why are we still having the same voltage? It's a parallel combination, guys, okay? So this is going to be 24,114 angle of minus 90 degrees. So as we saw last time, if you divide the numbers separately. So that's 200 divided by 24,114, which is 8,294. Then for the angles, you subtract. So here it was supposed to be 0 minus 90 degrees, of which minus, that's a plus. So we are going to end up with a plus 90 degrees here. Okay, so this is our IC, the current in the capacitor. All right, or you can write it in rectangular form if you want, guys. That's it. You can write in rectangular form. It's up to you. All right, so that's the currents in each and every branch we managed to calculate in the resistor, in the inductor, and also in the capacitor. So these are the branches that we're given: this branch, and this branch. Okay, the other part of the question is now to calculate the resultant current. All right. Remember, this is a parallel combination, guys, that we are dealing with here. And that's our total current here. If we are to check this total current, it's a combination of the sum of these currents, IR, IL, all these combined together. That's a parallel combination. You add, okay? In a series combination, current is the same. The total current is the one that is going to flow throughout. But here you add these ones together. Okay, so which means we're supposed to have something like this. I'm going to do it aside here. So this is question 2.22. So our total current is supposed to be the current in the resistor plus the current in the inductor plus the current in the capacitor. Okay, remember what we said, guys. It's best, very, very best when you are adding to add these numbers in rectangular form. It's best for you to add in rectangular form. Remember our R1, I'm just going to rewrite them here. Our R1, our current, sorry, in the resistor, it was 5 angle of 0. Our current in the inductor, if you still remember those answers, it was 2,792 angle of minus 90 degrees. Our current in the capacitor, it was 8,294 angle of 90 degrees. It's best for you to convert these to rectangular form so that you can add. Okay, so let's convert these to rectangular form. So the total current is going to be IR in rectangular form. Remember, guys, what I told you to convert to rectangular form. It's shift rec, which is shift minus. All right, then it's 5 and 0. So you separate 5, shift, you put this comma, that's a 0 like that. Okay. So X is 5, Y it's 0. So that means it's 5 plus J 0. Okay. So it's going to be 5 plus J 0 like that. Plus You move on to this one, 2 comma whatever that we have. Okay, so let's forget about the plus for now. So let's simplify first. Okay, so we are going to convert to rectangular form. So that's it, shift rec like this. You write the number 2,792, of which you can just, okay, do another way. Okay, that's minus 90 degrees for the angle. Minus 90 degrees, we've got our answer. X, it's a 0. Then y, it's minus. Remember, I told you that in the calculator is assuming you to have your complex number as x plus j, y like this. So x is real, y is imaginary, okay? So our x here, it's a 0. So it's going to be 0 plus 0. Then our j part, the imaginary part is having a negative. It's negative 2 comma whatever that we have. So it's negative j 2 comma, that was 2,792. Okay, you move on to the current in the capacitor again, you convert to Cartesian form. You do the same, shift rec, sorry, we need to convert to rectangular form. All right, so let me do this, guys. Sorry for this. All right, so we are going to do the same, shift, we convert to rectangular form. 8,294, then shift this one, comma, which is 90 degrees. So our x there is a 0. So we are going to have plus 0 here, plus 0 plus. The imaginary part is the one that is having x, which is the j. So it's the one that is having y. So this jy here, jy there, which is 8, so it's j 8,29. So it's j 8,294. Okay, so like I said, it's best, guys, to add in a rectangular form. Why? You just need to add the real numbers together. So you just add 5 plus 0 on your calculator, which is a 5. So that's going to be 5. You add the imaginary part together. So that's the imaginary here. We've got 0 plus minus 2 comma. So this one we can just use our calculator. So we've got negative 2,792. Okay, plus 8,294. Okay, so that's 8,294 there, 8,294, which is going to give us 5,502. Okay, so that's 5 comma. Okay, so we are going to have plus, it was a positive there, so it's plus j 5,502. Okay, so that's your total current, but this is in rectangular form. So you can convert this to polar form. How do you convert to polar form? Still, we are back on your calculator, shift to polar form, okay? So it's like this, shift, then polar form, shift, polar form, which is shift plus, it's now polar form. 5, then you separate, it's shift, comma, shift this comma here on this bracket, shift, comma on this bracket, okay? Which is 5,02, you close the bracket, okay? So it gives you R. Remember, in polar form, our answer is supposed to be like this. In polar form, Z is R angle of theta. So R is there. We are given there on our calculator direct. Okay, our R is, okay, let me change the marker first. So our R is 7,085, something like that. Okay, so that's our R from this one. Okay. 50, so that's in polar form, guys. Okay, that's 7,5. Okay, let me confirm again. Just want to confirm. So it was to polar form. So we had 5, okay, like this. It was 5,502. All right, like this. All right. So, okay, so which means I left the 2 there. That's why. So it's 7, 4, 3. Then this 5 can change this one into 5. Okay, so it's 4, 3, 5. Okay, so it is going to be 7,435. But remember, I told you it's angle theta. So it's going to be the angle, which is the phasor angle. And our theta is also given on the calculator. It just says to move this button to the right. Okay, your theta there is showing theta until you see your theta properly. So theta is 47, 7366 like that, which is 76737. Okay, so that's 47, 737 degrees. Okay, so that's your total current in polar form. If you want to leave your answer in polar form like this, that is what you're going to have at the end. All right, guys, as you can see, it's pretty interesting. Typical questions. They're very, very interesting. Then on the last part, which is 2.23, calculate the following using J notation. Now the power factor and the total power of the circuit. Okay, so now is the power factor and the total power of the circuit. Okay, so we know that our power factor is taken from the total current and the total resistance of the circuit, just resistance actually, the current through the resistance. Okay, so it's 2.23, where power factor is given as cos of theta. Okay, and we know that the cos of theta from the diagram is going to be the current across the resistor over the current, that is the total current. Okay, so that is the power factor. So you're going to calculate actually cos theta, then the power factor actually. So that's current through the resistor. We calculated that before. Okay, guys, this one we calculated before. If you still remember, okay, I think it was this side here. All right, there it is. That was 5 angle of 0. Okay, so I've got 5 angle of 0 there. All right, so I just hope we saw that one, guys. So I've got 5 angle of 0 here. Okay, that's 5 angle of 0 over IT with the total current here, this one that we see. So it's 7,435 angle of 47,737 degrees. Okay, so you just have to divide these numbers. Remember, I told you in polar form, you divide the numbers together. 5 divide by 7 comma something is going to be 0,672. Okay, and you subtract the angle, so it's 0 minus 47, which is minus 47. Okay, so that's 0, which is minus 47,737 degrees. So therefore, the power factor, you just write the constant with the answer, the resultant here, that's your power factor. So therefore, our power factor is going to be equivalent to 0,672. Okay, so that's our power factor there. Okay, I hope this one is clear. This one is clear, guys. On your formula sheet, this is given. Also, I'm going to show you the formula sheet in other videos that I'm going to do. I'll be working with the formula sheet so that you can also know how to apply these formulas. Okay, so remember it was power factor and also the power. So how do you find the power from the power factor? Power is given as VI cos of theta. Okay, so this is what is going to happen. We've got the voltage supply. From our circuit diagram, our voltage supply was 200 angle of 0 here, 200 angle of 0. So it is going to be 200 angle of 0 there, like this. So that's 200 angle of 0 times the current, which is the total current. Okay, so this is your total current, the one that we calculated before here, which gave us 7 comma this is okay. So this is your total current, write it as it is. So that's 7 comma 435 angle of 47 comma 737 degrees. Okay, times. Okay, we move on to the cos theta. So cos theta, you take this cos theta as it was before. This was the power factor finally, but cos theta is equivalent to this. So this is the one that we take 0,6, whatever that we got there. So that's 0,672 angle of minus 47,737 degrees. Okay, so that's it, guys. That's your power. But remember, guys, it's polar form. You multiply the numbers 200 times this. You multiply these numbers together. And that is going to be something like 999,264. All right. The angles, you add them together because you are multiplying. So that's 0 plus this. As you can see, these two will cancel each other. That's 0. And 0 plus 0, that's a 0. So this is going to be at 0 degrees. So this is the power that we are going to have in watts. Okay, so that was the last part of the question which was asking us to calculate the power factor, as well as the power for this given circuit that we had. Okay, guys, so that's what we had, guys, for Maths on African Motives on Industrial Electronics N4. Till we meet again.